Welcome back to VK Jain Sir की MEP classes by VK Jain. This particular series is about protection against lightning, module E18. Dear friends, I will let you know that there is one National Electrical Code of India revised in 2023 in parallel to National Building Code of India, which is of 2016 and to be revised in 2025. Friends, the most vulnerable and applicable code for lightning safety is Protection Against Lightning in India, governed by a standard derived from the IEC 62305. This is most vulnerable code in this direction, which has been adopted by Bureau of Indian Standard as IS/IEC 62305. This comprehensive standard details the basic principles, risk assessment, protection of structure, and protection of electrical and electronic system from both direct and indirect lightning strikes. Key components include the air termination system, down conductor, a robust earthing system, and a surge protection device, all of which require regular maintenance and inspection to ensure effectiveness. This is in four parts. IS/IEC Part 1 contains basic principles. The Part 2 contains risk assessment, and Part 3 consists protection of structure and life hazards. To be continued. The IEC 62305 series constitute the global framework for the design, installation, maintenance of lightning protection system (LPS) for structures and electrical systems. LPS stands for lightning protection and SPM stands for surge protection measures. You can see here, this is part 2 of 62,003 and 5, and it is divided in two portions. LPS is part 3 and SPM is part 4. Damage and loss relevant to structure according to different points of strike of lighting. This particular chart shows uh, 5 columns. The first column is point of strike, and second column shows you the diagrammatic representation of point of strike. The third column shows source of damage S1 to S4. There are 4 sources, and type of damage type D1 to D3, and type of loss L1 to L4. The following type of loss which may appear as consequence of damage relevant to structure are considered. L1 loss of human life including permanent injury. L2 is loss of service to the public. L3 is loss of cultural heritage. Fourth is L4, loss of economic value of structure, its content, and loss of activity. Friends, the lightning protection is achieved by following components of the system. First is first and topmost is air termination system. Then second in series comes down conductor system, and third comes earth termination system, and fourth lightning equipotential bonding, as is done in our metro systems, Indian metro system. Next is electrical insulation and hence separation distance against the external LPS. It may be noted, point 1, when an LPS is installed, equipotentialization is a very important measure to reduce fire and explosion danger and life hazard. This can be seen in part 3. Note 2. Provision limiting the development and propagation of fire, such as fireproof compartments, extinguishers, hydrant, fire alarm, and fire extinguishing installation, may reduce physical damage. Friends, now we will discuss the design of lighting protection system. The lightning protection system consists of both external and internal lighting protection system. Earlier, the IS 2309 of 1989 Code of Practice for the Protection of Building and Allied Structure Against Lightning, which likely superseded earlier similar code like 1969-70, provide the comprehensive guidelines for protection of a structure from lightning damage. Note that IS this 2309 of 1989 has been largely superseded by IS oblique IEC 62305 series of 2010, which is the current standard for lightning protection. Lightning system has got air termination, down conductor, joints and bands, testing point, earth termination, earth electrode, and fasteners. The part of lightning protection system includes air termination system that intercept the lightning strike using components like air terminals. Second in series comes down conductors, conductors that safely guide the lightning current to the earth. Then comes testing point, which is about a meter above the ground floor. The next comes earthing system that disperses the lightning energy into the ground. Next to this is equipotential bonding, ensures that all conductor parts of the structure are connected to minimize side flashes. Uh, we have earlier mandatory application part 8 of the National Building Code, section 2, electrical and allied installation, includes this. Friends, please Observe this particular diagram carefully, which shows the essential parts of a lightning protection system for buildings up to and including 60 meters. There is another similar diagram for height of the building more than 60 meter. We'll discuss only this. Now this particular shows air termination points, of course, 1, 2, 3 and 4. The next comes that in the periphery for every 30 meters the down conductor system are installed that are taken like this. Every 30 meter, this way or this way. So you can calculate the peripheral length on the terrace and come to know how many down conductors will be installed. We'll give the size of down conductor also. The X shows the minimum distance between down conductor here according to class of lightning protection system. There are 4 classes and distance may be from 10 to 20 meters. This distance of the down conductors. On the terrace you can see a grid of lightning conductors which are shown as having distances of they come in mesh, they are laid in mesh formation and the dimension of mesh size is shown in this chart. And at the bottom, after the down conductor, at the bottom are terminated into lightning earthing system. This earthing strips connects all earthing points, and at this point, at this height, nearly at this height, from the ground level, they provide a testing joint everywhere in all of the down conductor. That is for testing of the earth resistance. So let us revise the main components of lightning protection system are air terminations, then a mesh formation grid of lightning conductors. 3 metals are approved: copper, aluminum and GI. You can select from the table I will give. The second part of this is like down conductors, of which distance between 2 down conductor is dependent on the class of lightning protection system, and it may vary from 10 to 20 meters. Next is this from lightning protection system, a testing joint which is about 5 meter here, something like this, and then comes the earth electrodes and earthing strip joining all earth in parallel. Friends, first of all, we'll discuss air terminations. For purpose of lightning protection, the vertical and horizontal conductors are considered equivalent, and the use of pointed air terminations or vertical finial is therefore not regarded as essential except when dictated by practical consideration. And air termination may consist of vertical rod, catenary wire, mesh conductors. All the three. Air termination components installed on structures shall be located at corners, exposed points, and edges, especially on upper level of any facade, in accordance with any or more of following methods. One is protection angle method, second rolling sphere method, and third is mesh method. Horizontal air terminations should be coased along contour such as ridges, parapets, and edges of the flat roof, and where necessary over flat surface in such a way as to join each air termination to the rest and should themselves form closed network. Friends, we'll discuss the materials first. The material of lightning conductor, down conductor, or termination network, etc. of the protective system shall be reliably resistant to corrosion or be adequately protected against corrosion. The following materials are used recommended. First, copper. When solid or stranded copper wire or flat copper strips are used, it shall be of commercial grade with 98% conductivity and annealed and shall conform to relevant Indian standard. Second, copper clad steel or copper coated steel. Where copper clad steel is used, the copper covering shall be permanently and effectively welded to steel core. The proportion of copper and steel shall be such that the conductance of the material is not less than 30% of the conductance of solid conductor of some total cross-sectional area. Third is galvanized steel. If there is any difficulty in use of copper or aluminum, then galvanized steel may also be used. Where steel is used, it shall be of thoroughly protected against corrosion by a zinc coating. Galvanized steel may be preferred or for some short life installations such as exhibitions. This, friends, table 7 has been taken from our building code, National Building Code 2016, and it provides the material as well as the configuration type and their cross-sectional area in square mm. Say I'll take aluminum is recommended as a solid tab of size 70 square mm. It can be solid tab type or solid round type. You can use some more materials. You can use even stainless steel. This I have seen being utilized in Bhutan. After air termination and the grid formation, a down conductor carries the electricity in case of lightning strike up to the earth where it is absorbed. The energy of lightning is absorbed. Based on a standard referred by the National Building Code of India, which aligns with IEC 62305 Part 3 of 210. The size of down conductor for lightning protection system depends upon LPL level and material, but the minimum cross-sectional area required is, in case of copper, 50 square mm, aluminum 50 square mm, galvanized steel also 50 square mm or higher. Round conductor diameter as given here. In case of structure taller than 60 meter, skyscraper, uh, flash to the side may occur, flashes, especially to the point, corners and edges of surface. An air transmission system shall be installed to protect the upper part of tall structure, that is typically the topmost 20% of the height of the structure, as this part exceeds 60 meter in height, and the equipment installed on it. The rules for positioning the air transmission system on these upper parts of structures shall meet at least the requirement of LPL 4, which with emphasis on the location of air transmission devices on corner edges and significant protrusions such as balconies, viewing platform, etc. The layout of network may be designed to suit the shape of the roof and architectural features of the building. All metallic finials, chimneys, duct, vent pipe, railing, gutter, and like on above the main surface of the roof of a structure shall be bonded to and form part of air transmission network. If portion of the structure vary considerably in height, any necessary air transmission or air transmission network of the lower portion should, in addition to their own conductors, be bonded to down conductors of taller portions. Dear friends, due to time shortage and length of this series, I am reading only the important portion of this. It is very important that the down conductor shall follow the most direct path possible between the air termination and earth termination, avoiding sharp bends, upturns, and kinks. Joint shall, as far as possible, be avoided in down conductors. The formation of loop on the down conductor shall be avoided for minimum separation distance shall be maintained. Adequate protection may be provided to conductors against mechanical damage. Friends, I am reading only joint and bonds portion of this. The lightning protective system shall have as few joints as is necessary. In the down conductors below ground level, these shall be mechanically and electrically effective and shall be made as to exclude moisture completely. These joints may be clamped, screwed, bolted, crimped, uh, uh, riveted or welded. That's all. Friends, through this slide we are discussing wounds and testing points. External metal on or forming part of a structure may have to discharge the full lightning current. Therefore, the bond to the lightning protective system shall have a cross-sectional area not less than that implied for the main conductors. On the other hand, internal metal is not so vulnerable and its associated bonds are at most only likely to carry a portion of total lightning current apart from their function of equalizing potential. These latter bonds may therefore be smaller in cross-section area than those used for the main conductors. All the bonds should be suitably protected against corrosion. Bonds shall be as short as possible. The next is testing points. Each down conductor shall be provided with a testing point in a position convenient for testing but inaccessible for interference. No connection other than one direct to an earth electrode shall be made below the testing point. Testing point shall be of phosphorus, bronze, gunmetal, copper or any other suitable material. Friends, now we are discussing earth terminations. Each down conductor shall have an independent earth termination. It should be capable of isolation for testing purposes. In a structure where only electrical systems are provided, a type A earthing system arrangement may be used, but a type V earthing arrangement is preferable. In a structure with electrical systems, a type B earthing arrangement is recommended. Water pipe systems should be bonded to the earth termination system if adequate clearance between the two cannot be obtained. They may be effectively bonded and the bonds should be capable of isolating and testing. The gas pipe, however, should not be bonded to earth termination system. It is recommended that all the earth terminations should be interconnected to a common earthing. Besides equalizing the voltages at various earth terminations, this minimizes any risk of mechanical damage. A structure standing on bare rock should be equipped with type B earthing. The ring earth conductor encircling the structure shall be embedded inside concrete, preferably installed 1 meter away from the building, where there is no risk of persons or, or to the vulnerable equipment. Expert advice should be sought. Friends, in the previous slide, we have come to know about type A and type V systems. We'll discuss more about this. Type A and type V are respectively linear rod wire and ring oblique mesh lightning earthing system defined in IS 62305 part 3 for lighting protection. Type A uses individual vertical or horizontal electrodes connected to down conductors and best for small or low-rise buildings. Type V utilizes a ring conductor buried around the structure or foundation electrode, offering better, more reliable grounding for sensitive electronics or high risk sites. Um, Regarding type V earthing system, it is mandatory for structure with extensive electronic systems, high, high fire risk or complex infrastructure. It is also mandatory for structure with extensive electronic systems, the same thing. Regarding earth electrodes, so-called earthing pits, each electrode shall be constructed and installed in accordance with IS IEC 62305 Part 3. Earth electrode shall consist of rods, strips or plates. Metal sheath of cable shall not be connected used as earth electrode. When rods or pipes are used, this should be driven into ground as close as practicable, but outside the circumference of structure. Long length in sections coupled by screwed connection or socket joint cannot be built up where necessary to penetrate the substrate of low resistivity.